specific areas related to university-industry collaboration. Specifically, IBM's program of university relationship has been one of the ambassadors who has been doing it. So for me, the single point of contact at IBM for any academic training program or any kind of program is Dr. Mani Madhukar. So he is a global university program leader at IBM Research, and he has exposure to both industry and academia. He holds a doctorate in computer engineering and executive program management from the University of Virginia. He's very passionate about learning and sharing knowledge. And his work area include academic program management, which is very important because these days universities, institutions are expected to have more collaboration with industry for fruitful research and teaching and training. He has worked on many important IT areas like cloud application development. He has also mentored quite a few startups. He has helped universities in curriculum design and development. He has also done so many project management as a part of IBM and as a part of his IBM work. He has been into electronic content management, competency development. As I told you that we have had several programs jointly with IBM, and IBM Cloud pre-sales for infrastructure and platform services. As a part of IBM, he has worked in various roles in different technology, including, as I told you, cloud, blockchain, for which we invited him here, Internet of Things, data science, DevOps, and IBM Watson, one of the most important application or tool. So he has many patents to his credit in blockchain. He has research papers in conferences and reputed journals. And he has also contributed a few chapters to several books in these areas. He is a reviewer of a couple of journals, author to various blogs. You can find out his blogs. He has been associated with universities and institutions as adjunct faculty and research co-guide. Mani represents IBM in various forums as a technical expert, panelist on various technology areas, and advisor to a few incubation centers and a startup as well. He mentors online community on blockchain and cloud, supporting sessions on IBM blockchain, Hyperledger, and IBM cloud. He's also an expert on curriculum design. So, Professor Dr. Mani, we will be taking your help in another program in which we are planning specifically for curriculum design in view of the NEP and for colleges and institutions to help them so that they come out with a wonderful curriculum. So with this, I invite Dr. Mani Madhukar to please deliver his lectures on Hyperledger Fabric, which is one of the most important platforms for enterprise level blockchain development. Thank you, Dr. Mani, for accepting our invitation. On behalf of all the academies, there are 5 participating academies. On behalf of all the academies and our coordinators, Professor Amey Karkare from IIT Kanpur, Dr. Prabhat Kumar from NIT Patna, Dr. Satish from IIT Roorkee, and myself, we are all so glad that you have accepted our invitation. Thank you so much. Dr. Pilli also, I'm sorry, I forgot to tell the name of Dr. Pilli. He's also one of the coordinators of the program.
So, ma'am, thank you and good morning from everyone.
So I stop sharing and give you the...
Yeah. I I really hope that you are having a great learning session. I saw the complete schedule; it's wonderful. And thank you for this opportunity. Thank you for inviting me here today. So I'll be, in my session, I'll be focusing on Hyperledger Fabric today, and along with that, what I'll also be doing is while discussing about the Fabric concepts, I'll also show you how it is offered as a service, how blockchain is offered as a service on cloud,
Link.
and even how you can actually, get access to the same. So I'll discuss that aspect as well in the course of this conversation. So, as I understand, you already have a sound
आप उससे ले लीजिए
understanding
ना,
of sound
उससे
knowledge
ले
of
लीजिए, हम कैसे
blockchain
दे अब हम
by the time you and me are interacting,
चालू
right?
कर
So,
दिए अब हम हैं.
multiple sessions have already happened. Multiple experts have already taken you through that particular content about the types of blockchain and other. The conversation today that I'm going to do is going to be focused around private permission blockchain. So I want you to be very sure, and you should be seeing the content or discussion in that perspective, right? So we're going to talk about private permission blockchain, which are the ideal way how enterprises see it, right? Since I come from IBM, so I can talk about how enterprises are adopting blockchain, right? I'm not talking about public permissionless blockchains, right? So I just want to make this very clear before I get started with this. So
recording in progress.
Okay, so let me get started. Okay. Well, this is just to be on the lighter side of things, right? So we see blockchain everywhere today, right? So whatever conversations are being driven in boardrooms, are being driven in, all these with VCs, right? All these startups, we see blockchain everywhere, right? And hence, it's really important for us as in you and me, right, as an academicians, to really get a hang of the things that what this technology is, how people are looking to use this, or how people are already using it, right? So this is so much in demand, so much in focus today, and that's the reason why there is so much of focus on learning blockchain in academia, whether it's from a research point of view or from an application point of view, right? Whether we talk about blockchain is really something which people are really looking forward to, right? And different people have different perspectives about blockchain, right? Some could actually just talk about it like a linked list, right? Few of them may actually say that we don't need it. We have so many other technologies there, right? Having said all that, blockchain have their own space there in the technical, in the overall, space things in the, and we really need to find the right use cases where we can make use of blockchain as our technology implementation, right? Yeah, so we talk about the Internet of Trust. That's what blockchain typically provides. So we are looking to build trust with control, transparency, traceability, so that why are we doing it? We are doing it so that we can actually have a business perform in a better way, right? Because now when you have trust along with that, when you have trust built into the system, right? So that's when the businesses are a lot more better. Okay, so I'll skip a few slides if you don't mind. This is just sort of a couple of statistics around why is blockchain so important. This really helps in sort of helps in trying to get a perspective that why we should be interested in blockchain. So as said, almost 10% of the global GDP is going to be stored in blockchain in a couple of years from now. As we are already aware, a lot of banks have already some application of blockchain, and they are continuously evaluating how they can bring in more applications on blockchain, right? So there is even a couple of dedicated consortiums also which are formed around banking. We'll discuss more of that in detail, what the use cases around blockchain. And yes, of course, the value, then the business value which is basically being added by blockchain, almost like 176 billion, which is going to exceed up to 3.1 trillion, right, in maybe next few years again. So now the major challenge that we see there is, right, the knowledge gap, the overall trust gap. That's where we are looking to sort of bridge through these programs, right? I'll try to take a simple example, and then I will, go ahead with my presentation. Now, I'm sure you're all familiar with supply chains, right? Where there is a lot of material going back and forth between multiple stakeholders, right? You talk about food supply chain, you talk about a car manufacturer supply chain, whatever. This is a simple example, right, which talks about a car manufacturing supply chain, right? Now, if you see there are hundreds of suppliers which are providing the manufacturer the components of the vehicle, components of the car, right? And then the manufacturer may have tens of plants where they are doing assemblies, right? So there may be an engine assembly plant separately compared to there would be a shipping plant. They may have a testing facility separately, right? And then they would actually bring all of these things together to an assembly line, and then again they may have multiple plants for assembly as well, right? And from the assembly line, the manufactured product for the car actually goes to multiple dealers, and finally they'll end up with customers. Now, if you see the entire supply chain, there are hundreds and hundreds of moving parts in this, right? Whether suppliers or manufacturers or dealers, whosoever we're talking about, right? Now, it's really very difficult to manage this in a conventional approach, right? We'll see that how. So that's where blockchains really come up. This is another example where we talk about a food supply chain, right? Again, you can see there are multiple stakeholders, right, from seed provider to fertilizer providers to merchants to third-party equipment suppliers. A lot of there. And then you have entire food industry there. You have financial services. You have insurance companies. Now we see in agriculture there is a lot of insurance industry which is there, right? So the point is there are a lot of people, there are a lot of stakeholders, and there may be a lot of intermediaries as well, right? And the current state of things is more like paper based, right? Which is not almost or always in real time. And each of these stakeholders maintain their own record of transactions in their own ways, right? They may not be compatible, right? Somebody, let's say a farm owner, the way he manages his record, given case he manages, may not be the same way, how a corporate, agriculture corporate maintains the records, right? So, and it's really difficult to reconcile when you are having or you're looking to map the records back to where it originated from. So that's where is the challenge. Similarly, if you talk about how in international trade payment system, right, cross-border payment system, how the payments are done today, this is again a very complex chain with multiple intermediaries and hardly any transparency, which is even costly because of multiple intermediaries sitting in between, right? So again, blockchain is revolutionizing or changing the way it happens here. So when we talk about blockchain, we talk about multiple technologies, multiple what do you say, multiple things together, right? Whether it's mining or it's consensus or hashing or ledgers or peer networks, whatever, right? So we talk about multiple things about. I'll skip a few things because I'm sure you're already covered, all of this. When you have a Genesis block, then you have multiple blocks come and getting added to that overall chain of things, right? Uh, we will broadly focus on two things: consensus algorithms from a hyperledger point of view, and how transactions happen in a hyperledger scenario, right? I'd like to draw your attention to this. In all the previous slides, we talked about the conventional approach, a business approach, where there are multiple stakeholders who are managing their own system of records, right? Now, mostly paper based, and the major problem with this is, all of these actually are like, there's so much of redundancy in this, and they are actually they're in silos and they're not talking to each other. So it's really difficult if you want to sort of see them in the. So if you want to ask a particular transaction, what's the state of a transaction at a certain time, the state of transaction may vary for all the different participants, right? Because all of them will derive their truth from their own system of records, right? And so let's say a simple example. Let's say A is a buyer, B is a seller, right? I'm taking a very basic example here. Now, A made a remittance to B as an advance for buying something, right? So the moment A made that remittance, A's bank account gets debited with that X dollar or X value, whatever excess, whatever participant A is paying to B as an advance. Whereas it will take a few days to reflect, in B's account, right? So if you see there is disparity in the accounts at a given point in time, isn't it? So it's really important that we understand that how the vulnerability gets added because of this inefficient mechanism of storage of records, right? Now, what blockchain brings to the table is a consistent approach, which has a shared, replicated permission ledger sent between all network participants, which provides for consensus, provenance, immutability, and finality. So I understand that you would be familiar with all of these things. So I'll not dig into all of these for now, right? So broadly, four things that we talk about as required for business and for as far as blockchain is concerned: a shared ledger, which basically has is the ledger between all the participants. Then an identity, right? That's where we differentiate from a public permissionless blockchain, right? An identity, because when you are doing a business, unless you are doing a business on a dark web, you need to know whom you are doing a business with. So hence, identity of the participants is very important. Then endorsement, we'll talk about it in detail. And of course, the confidentiality, right? Like how much information to be shared with whom on this network. And that is basically on a need to know basis. So we control all of that through cryptography. This is just a recap, which you would already be knowing about, like how you control the identity, how you do the endorsement. We'll see that from a fabric point of view, and how cryptography is key whenever we talk about maintaining privacy and confidentiality on the network, right? So what is the benefit that the blockchain brings to the table, right? It basically brings that irrefutable proof for any transaction to have occurred, right? And so this proof is really something which is important. Now, a lot of our activities on a day-to-day basis, if you do, we are very skeptical when we do it. When we make a payment to somebody whom we don't know, and when we make a buying agreement, or when we purchase something of high value, trust is something which comes everywhere to in information, right? And that's where blockchain really comes handy for adding that irrefutable proof that transaction did occur, right? And you can revisit that every time back and again, right? Wherever you want. Now, I want you to actually, I'm sure you might have been doing this, but then I want you to actually think through, and we will discuss, we'll come back to this question again in later on. Think of an example, think of a place where you would like to implement blockchain as a technology in your day-to-day, whatever you do, right? Whether you are teaching, whether you are doing research, whatever you're doing, try to think one example. How do you think blockchain can make things better for you there, right? And we'll come back and we'll discuss more of this again. So let me go back and let me go to the Hyperledger that we are going to talk about today, right? Now, as we all know, Hyperledger is a collaborative effort which was created to advance blockchain technology, right? And not very old, right? This project actually was founded in 2016, and since then, if you see on the right hand side the different logos there, so those are different type of partners, right? There are premier partners, there are general partners, there are associate partners, there are even academia associates who are connected with this project, right? So Hyperledger Fabric is actually one framework which is one under the Hyperledger umbrella, and there are so many, right? For Fabric, there are multiple contributors, including IBM, DTCC, Fujitsu. There's so many of them you can see over there, right? So IBM is just one of the contributors to the Hyperledger Fabric platform. And then there are so many other platforms, other frameworks like Iroha, Sawtooth, and so many more of them, right? Now, why Hyperledger? Why we are talking about Hyperledger today? And I'm sure you might have gone through a few more frameworks from a few more platforms in the course of last couple of days, right? Now, from a enterprise adoption point of view, right? No enterprise, let's say if you're looking to adopt to blockchain as a technology, right? So you're looking for a, like 50, 60, 100 years of particular technology adoption, right? And hence, no enterprise would like to get into a vendor lock-in. Now, what I mean by vendor lock-in is you subscribe to a product from X vendor, and then you cannot move out of that arrangement even if you are not happy, right? I'll give you another example just to clarify my point. let's say you decided to have a university management system developed in, let's say, Java, right? At some point in time, it seems that you're not happy with Java, or it seems the functionalities that you want to implement are no more supported through Java. Again, a hypothetical example, right? And then you want to move on to, let's say, C sharp, just an example, right? In order to do that, maybe you'll have to rewrite the entire code. You know, that means the entire effort, and besides the overall journey that you already would have with that application. Let's say you already had implemented plus 20 years that Java program that was running the system for you, the application for you. So that means all that 20 years of record, besides, and the entire redevelopment of the application in, let's say, C sharp, is a humongous effort, and of course a cost taking as well, because you'll have to have systems in place, you'll have to have a development team in place, you'll have to invest some time in that, and then you'll have to find ways to port the historical legacy data back into the system so that you can leverage the historical transactions that has happened in the past, the last 20 years, right? So all of that is like, you're getting locked into a particular platform. Here we're talking about a vendor market. So from an enterprise point of view, why is Hyperledger important, right? Because it provides for open governance, right? So there is no one organization which is controlling the entire project, right? And hence there is no lock-in with one particular vendor. So let's say there is a company, IBM has a use case on BNFS, right? Let's say MX has another use case maybe in some other segment, right? So when you actually look from an application point of view, so the requirement of a blockchain platform can greatly vary across different use cases. There cannot be one size that fits all solutions. And hence, it's very important for an enterprise to look for a framework, to look for a platform which provides for open source, open standards, modular, pluggable options, so that they can switch as and when the requirement changes. And that's where Hyperledger has a clear differentiation from other platforms, right? As I was telling about, right, there are multiple projects under Linux Foundation Hyperledger project, right? So you got multiple distributed ledgers like Mesu, Burrow, Fabric, Indy, Roha, Sawtooth, right? Similarly, you got multiple libraries like Ursa, Quilt, and all, right? And again, they're provided for a lot of tools which can be used on top of this, like Avalon, Cactor, Caliper, Cello, and all, right? So this is actually a very broader umbrella which provides for a lot of great things. So from a Hyperledger point of view, the objective is to create an open source distributed ledger framework and provide the code base upon which users can build and run robust platform specific applications, right? And again, at the same time, it's also the intention to provide a technical community which can work for benefiting, or which can work for upliftment of the platform, right? So if you see, there is a very strong Hyperledger community which keeps on adding to various things, various components. You can even go ahead and you can propose some labs there on the Hyperledger. You can even go and add and suggest those there. So a lot of stuff around there which provides for open standards and open governance of the project. Now, ever since the first release 4.6, Hyperledger Fabric has seen multiple releases in the last couple of years. Right? Now we are actually going with 2.x series right now. Right? So we'll try to discuss the latest one there. What is typically there, right? But the key characteristics from a enterprise adoption point of view is permissioned blockchains. We're talking about they should be providing for privacy. The solution should be the platform should be highly modular, which can provide for pluggable consensus, certificate authority, whether external certificate authority or internal certificate authority, right? The smart contract should be supported by multiple languages, right? So right now, for example, for Fabric, we have support for Java, we have support for Node.js, right? We have support for Go, we have support coming for Python. Here, from my enterprise adoption, we do not talk about any mining sort of a consensus mechanisms, right? So we have a couple of mechanisms approach which are implemented for ordering service. We'll see that in detail. So four key components when we talk about Fabric: one, certificate authority; two, the peers; three, the ordering service; and four, the channel, which basically connects all these three stakeholders, right? So this is just one sample network where there's a farm, agriculture farm, there's a buyer, there is a shipper, and all of them are connected through channels. So we'll discuss more about channels in due course of time. Guys, in case you have any questions, feel free to put it on chat. I'll be more than happy to pause, take a look at the chat window, and maybe answer those questions in a while. Okay, so I'm sure you're already familiar with these typical concepts of assets, contracts, transactions, business networks, and participants, right? So participants are interchangeably being called as nodes. We'll use that terminology often when we talk about going further, right? Transactions typically are the invocation of algorithms, whatever we are looking to do on the network, right? Contracts are what we talk about as the algorithms, right? Which is agreed upon between you when you start something. And assets are something that changes hands, which is modeled as data structure. Okay? So okay. Just a moment, please. Okay. Yeah. So what we are trying to achieve with Fabric is we are trying to achieve a multi-party transaction using Fabric, right? So a transaction is like when I sell my vehicle to somebody else. Let's say I sell my car to Samir, or I buy a car from Samir, right? So that change of ownership of that asset is basically a transaction whenever there is a change to the system, right? Similarly, whenever you write a check for somebody, there is a change in the overall bank, right? Whenever a student receives any qualification, let's say somebody completes his subject, right? So that's basically a transaction which is sort of getting completed. So normally, when we talked about transactions are signed by single organizations, right? For example, if there is a degree to be signed, the degree would be signed by a typical university registrar or vice chancellor and all, right? Now, similarly, if you're looking to sign up or looking to make somebody a payment from a bank signs that payment transaction, right? So the point I'm trying to make is traditional transactions were more like single organizations. Now, what we are trying to talk about here is multi-party transactions where there are multiple stakeholders who are signing the transaction so that the transactions can be authenticated, so that the consensus can be arrived, and so that the transaction can be irrefutable, right? Yeah. So, for example, if you are trying to receive or send a parcel to somebody, right? So the sender and the receiver both sign that transaction. Now, let me make one thing very clear over here, right? So I've been associated with a lot of companies, startups who have been, whom I've been working with for adoption of blockchain as a technology. Now, blockchain as a technology only makes sense when there are external stakeholders to the business. Blockchain is not a good technology when you talk about implementing within your university, right? But then when you're looking to collaborate within multiple universities or maybe multiple stakeholders, like say some industries, a few more universities, when you bring them together, that's where blockchain actually makes sense, right? Because there is an inherent issue of trust between these multiple external stakeholders, right? So that's why we're talking about multi-party transactions, right? So if you see there, if you see the right hand side, the response is basically being signed both by the seller of the car as well as the buyer of the car, so that a transaction of car can be authenticated, right? Similarly, if you see, from a transactions endorsement point of view, Fabric is built on selective transactions. So we do not say that all the stakeholders should be, sort of validating or endorsing a transaction. I'll take you through an example when I talk about the consensus. I have a small, sort of a role page to do there. Do it there. So for now, we'll just try to understand, in order to be, for any transaction to be valid, right? The transactions should be endorsed using some endorsement policy, which should be agreed upon by the stakeholders. Now, what can be the size of the stakeholders? Who would be the stakeholders? We're not getting into that for now, right? But in this example, the one that you see of transferring of a car, here there are two stakeholders, the buyer and the seller, right? So the endorsement from both of them makes sense here, right? Or maybe the regulator, the government regulator, right, RTO or somebody else, who is basically facilitating or vetting this transfer, right? This is just basically a snapshot which talks about transaction endorsement, right? So transaction can be invoked by somebody and it can be endorsed by somebody else, right? So depending upon the nature of the transaction, right? So let's say there is a transfer of a vehicle happening from an organization one to an organization two, and the asset name is car one, right? If you see the statement there, so the invoked transaction is transfer of car one to org two, right? And who is invoking it? It is basically invoked by the owner of the transaction, which is org one. Now, see this. This needs to be endorsed by the rightful stakeholders, right? So here in this case, the rightful stakeholders are org1 and org2, which is the buyer and the seller, right? Similarly, if you see some other, let's see, some other transaction, so you'll find the set of endorsers to be changed according to the policy. Now, see, if you want to change the rules, let's say we want org1, org2, and the regulator also to validate the transaction, endorse the transaction. Now, if you have to update the rules, see the last entry there. You need to actually, update. You need to invoke the update policy, and which has to be enforced by all the stakeholders in the system there, in the network there, right? So, yeah. So let's go further and let's talk about a typical hyperledger transaction, right? A fabric transaction. So the structure of a transaction is like an identifier, which is nothing but the ID identification of the transaction. And then who is the proposer, right? Who is the initiator of the transaction, right? And then the response, we call it as RW sets, the read and write sets for the transaction. What will be the result of the transaction, right? And once the transaction is validated, that is, it is being signed by multiple organizations, that's when it actually becomes a transaction, right? It's not before that. That's when the transaction is written onto the ledger and the asset transfer happens to take place, right? Okay. I'm sure you understand about smart contracts. We also call them as chain codes. So you'll see this term getting used interchangeably. Now, smart contract typically is the one which generates the transaction response, right? So in smart contract is like a business logic which is embedded in the code, right? And it's defined to control the access to the ledger. It is, it uses transactions to basically process it from the application. And the smart contract also does the execution. And of course, since the smart contract sits on multiple nodes, right? So accordingly, there can be a smart contract for different business activities. For example, in this case of a car transaction, let's say the buying and selling of a car is like changing of the ownership of asset. So for this, there can be one smart contract. Now, if you want to check the history of ownership of the asset, or if you want to check the history of accidents which might have incurred on that particular asset, let's say car, what's the insurance history of this car? Now, for that, there may be a separate smart contract for that, right? So that transaction response is basically being generated by the smart contract. And of course, we talk about a ledger, which is an immutable history of all the transactions, right? We'll see when we talk about from a fabric point of view, there are two data structures, right? One is the blockchain and other is the world state, right? So the blockchain is typically where we have all the historical transactions stored, whereas world state is something where the current value of a particular asset is stored. Let's say, for example, the one that I was talking earlier. Let's say I'm looking to buy a vehicle. Let's say I'm looking to buy a car from Samir. Okay, so the current owner of the asset is Samir. Okay, so if you see in the world state, the car one owner is Samir. Instead of org2, let's say Samir. Now, let's say I'm I have completed the transaction. I've made the relevant payment to Samir, and the ownership has got transferred to me. So the moment that happens, the historical value of the car owner, which is Samir, gets into the blockchain, whereas the current owner of the car, which is money, gets updated in the world state. So the immutable ledger is the blockchain, whereas the world state is a mutable. You can always keep on changing, keep on updating that. Now, it's really important, from a permission blockchain's point of view, that all the users have an identity, right? Now, in Fabric, we provide for X.509 based certificates and private keys, right? And we have both the internal certificate authority, and we can even have an external certificate authority, which provides for various keys to the different stakeholders, different network participants. We'll see more about it in due course of time. Okay, let me go further. So as I was saying earlier, typically a blockchain network is a consortium of multiple organizations. Blockchain is not a good technology for single organization adoption. Why? Because of the overhead it brings in terms of consensus and other things, right? Within an organization, you do not have an issue of trust, right? Because you all are part of, the entire processes are part of one organization. So you do not need to bring in that angle here, right? There is a natural trust, whatever, different organizations, different departments are doing in one organization. When there are multiple organizations, doing businesses with each other, that's where you talk about, blockchain, right? So coming back to the same point here, before you start doing a business, you need to agree upon some business rules, some logic, some guidelines, right? That's where we talk about, the smart contract, having all the business logic embedded into it. And that's why we talk about the endorsement policy. What is going to be the endorsement policy? How are you going to accept whether a transaction is valid or not, right? So all that consensus mechanisms actually kicks in here. Okay. Now, from a blockchain point of view, solution point of view, there are two major components. If you see from our application side, right? One is the smart contract, which has all the business logic, and second is the underlying network, right? The business network which connects all the nodes or all the participants of the business network, right? So broadly, if you ask me, two major components. One, the network part, the underneath network part which connects all the participants, and second, the smart contract or the chain code which sits on top of it. So typically, let's say there's an organization, one, there's a manufacturing corporation, there is a dealer corporation. Then if you see there are multiple nodes in each of these corporations, right? So in manufacturing, there is a tier 2, tier 1, tier 3, and then there is in a dealer corporation, there are again some nodes, peers are being used interchangeably, guys, right? So a peer typically is one which has a copy of the ledger, right? And then we have different types of peers. We'll have endorsing peers. We'll see more of it. For now, just try to understand that blockchain has two major components, right? The smart contract on top and the underlying network which connects all of them, right? So here we are trying to talk about the underlying network here, right? So there is a certificate authority, there is an ordering service, right, which basically tries to bind all of these things together, right? And if you see there, uh, there there is there are all of these things basically are connected to each other. Each of these nodes talk to the certificate authority in their relevant corporation. So, manufacturing corporation have their own certificate authority. The dealer corporation have their own certificate authority, right? Whenever there is either a query happening or a transfer application happening, right? They all need to go back and they all need to, write the transaction on their ledgers. Now, ledgers are basically they are residing on each of these nodes, right? And we'll see like which of these nodes have a copy of the ledger and which don't have a copy of the ledger, right? So we'll see that. Okay. Uh, so second component, right, the fabric piece where all the application comes and sits, right? Okay, let me quickly show you the various actors in a blockchain system. So, so we have a blockchain architect, we have a developer, we have a blockchain network operator, right? This is where the segregation happens, right? So one piece is basically maintained by the network operator. Now, cloud service providers like IBM and a couple of others offer blockchain as a service, right? Using which you can spin up a blockchain, service instance which takes care of the underlying network for you, right? So it will create up a network, it will spin up those multiple nodes, you can have multiple organizations created there, and you can have multiple certificate authorities for different organizations there. And so all the entire network piece is basically being taken care of by these cloud organizations, right? We'll see a demo of this service in due course of time, as we go further. And then comes the second part where you architect the solution, right? And that's where it's basically being developed by the developer and you put it. So that's the two components which I was talking to you. Now, from a actor's point of view, you have those blockchain users. These blockchain users can have varied interest on this solution, right? For example, an insurance company can be more on this network from a from a overseeing perspective, whereas the buyer or seller can be on this blockchain network, for doing a transaction. And then we have a regulator, right, which again performs oversight. And you have these membership services connected to this network. You can have traditional data sources coming and getting plugged into the blockchain network. And of course, you have system of existing records which come and tap into the blockchain network there, right? So these are multiple actors there, and they manage different pieces in this overall network system, right? So as I said, right, the blockchain network operator manages the entire connectivity and monitors the network between multiple stakeholders which are connected on this blockchain network. Similarly, the regulator is more like doing the overseeing work, right? Just that the compliances are met, whatever checks and balances are being put by the regulator, they are taken care of, right? That's basically the role of the regulator over here. I'll give you an interesting story that how is regulator so important when you adopt blockchain solutions, when we talk about the use cases there, right? And then these are the various components to the blockchain system. We talked about all of these in different places, right? What is membership, what is peer network, what is ledger, what are the various events, what is wallet, where you store all the security credentials for the different nodes, all of them, right? So typically, a hyperledger fabric network comprises of set of nodes, right? Org1, Org2, Org3, let's say in this case, right? And these peers are, again, they simplify or they signify different organizations that can be any number of nodes on that, right? These peers connect with each other. If you remember, we talked about channels, right? So they connect through channels, they communicate through channels. Now, the channel basically defines the scope of network. What does it mean? If org1 and org3 are directly connecting to each other, they may have a channel between them as well, to which org2 is not a party. Whereas org1, org2, and org3 can be part of one common channel on which whatever communication they do is visible across all the three organizations. At the same time, if org1 and org3 are connected on a separate channel as well, so whatever communication happens, whatever ledgers are basically maintained, those will be native to only those two orgs, org1 and org3. Org2 will not be party to whatever conversation, communication is happening, or whatever ledgers hold on that channel, right? So that's what the scope of network means. Okay, and each node can be part of any number of channels, so that's not the case. Okay, this is what I was talking to you about earlier, that here we talk about two data stores, right? One is a blockchain, which is nothing but a linked list of blocks, and second is the world states. uh, it's the blockchain which is immutable, right? Blocks cannot be tampered. Why? We know the hash of the previous block is used to encrypt the next block, and so on and so forth, right? So the first block of the blockchain is the Genesis block, and then as you keep adding the blocks, right? And we just understood that the hash of previous block, so hash of n-1 block is used to encrypt nth block. Similarly, the hash of nth block is used to encrypt n+1 block, and so on and so forth. So the point is, the longer the chain grows, it's not possible to tamper. The moment you try to tamper, you even try to edit one bit in a block, and that chain the hash changes, right? So that's why it is typically immutable. Come the second data store, which is the world state, which is nothing but a key value store, right? And it stores all the outputs of all transactions, and this is something which is not immutable, right? So you keep writing onto that. Right? Now, how do you actually work between the application and these data stores there, right? So the application will typically invoke some query there, which is passed on, which is processed by the smart contract, and based upon that, it basically goes and it tries to query the world state or the blockchain, right? Depending upon how it actually wants to be. So, in order to understand the ledger, right, applications submit the transactions through the network, right? And network is basically where the smart contracts are there with some set of parameters. Now, transaction order and output is agreed by the network through the consensus mechanism, which is already in place, right? And world state is complemented by something called as a private data collection. I'm parking this conversation for now. This is just sort of a snapshot at how a particular private data collection looks like, right? What's the private and what's the public state? So a particular data store can be private to some data, some stakeholders, and something can be made available to all the organizations, right? So let's say in this case, the owner name may be private to, let's say, the RTO or the police, which may be owning the ledger, but then the car, the model name, the other specifications of the car may be available, on a ledger which is publicly available to all. Why? Because all the other stakeholders will be querying this ledger, right? Okay, so this is where we talked about how the application is interacting with the ledger, right? So you have a blockchain developer which develops the client application using SDKs. So if you talk about from a fabric point of view, there are SDKs available for Go. That's the actual thing which the fabric is written on. Then you have SDKs for Java, for Node.js, right? And then there is support for Python, right? So using that SDK, the application actually connects with the smart contract, right? And it then, based upon what operation does it wants to perform, connects with the world state or the blockchain and accesses the same, right? On the blue blocks that you see here, those are the ledger. That's basically the ledger which we are talking about over here. Okay, I'll skip this private data collection. We will come back to this later on. Yeah, so we'll come back and we'll see the other pieces later on, the private one. Let's talk about the nodes. What are the different types of nodes? What's their role here, and how do they actually they're instrumental in doing a transaction? So typically, we talk about committing nodes, we talk about endorsing nodes, we talk about ordering nodes, nodes or service, whatever you would like to actually talk about, right? So please notice the color coding there, right? We will use the same color coding as we go further, right? So each organization agrees to a certain policy, which we will be adopting on the network, right? So all two agrees to certain policy. So that this policy is nothing but like a constitution, which actually every organization will agree to, right? So every, I was saying about, we're talking about a peer-to-peer network here, right? So every organization has the same authority over the network, right? There's no master slave concept here. All organizations must agree to any change to the network, right? So if there is a change happening in by some transaction, so as org2 gets updated, the same gets updated across all the other organizations. All or many, right? A majority of organizations must agree to any change in the network, right? And a majority of organizations, including the stakeholders, should agree to a change, right? It's really important. That's what the entire policy is all about, right? Hyperledger Fabric uses identity and policy throughout, so it's really important. That's why I said that towards the start of the conversation, we're talking about permission blockchains here. We're talking about private permission blockchains here, right? So typically an application connects to a gateway using an identity from the wallet, right? If you see, this is a snapshot of one organization. There are two peers, P1, P2, running a smart contract S, right? They will actually select the available network and a smart contract depending upon the business operation that we are looking to perform, right? Once they submit the transactions, right, submits the transactions and checks their responses, they typically, disconnect from the gateway. Okay, so this is how a submission happens I'll show you the complete flow of the transaction in due course of time. This is only from a broader understanding that how a SDK connects to an ordering service or to a membership service and so on, right? So before anything starts, right, a client application has to enroll with the membership service in order to get an identity, right? We said that. Now this membership service can be internal to the organization or it can be an external third party as well, something like a VeriSign or somebody else, right, which can play that role, right? So you enroll. So once you get the identity, then you submit the proposal to the endorser node, right? I'll just explain that in more detail. I'm just trying to explain this infograph. The endorser basically, returns some responses. Based upon those responses, you forward all those responses typically, right, and to the ordering service, right? And then the ordering service provides all of them to the committing node, right? And then finally the committing node again runs some smart contract based upon which it checks the validity of the submitted transactions. Okay, let me take you through this step-by-step flow, which talks about the complete transaction. So client application, let's try to understand the network first. So in this network, there are multiple nodes as you see, right? E0, E1, E2 are the endorsement nodes. P3, P4 are the committer nodes, right? And then you see the smart contract, E0 is running a smart contract A and a smart contract B. Another endorsement node E1, E2 are also running two smart contracts for business process A and business process B. Okay. Now, the committer P3 is running two smart contracts again. If you see there, one is for a process A and another for a process B there, right? Now, and then there is the ordering service. Okay, so we are talking about a high availability ordering service over here, right? Okay, so let's try to see what is happening here. So the client application through the SDK has submitted an application to endorsement nodes E1, E0, E1, and E2. Okay. Okay, let's see what happens next. So the endorsers basically execute the proposed transaction. Let me take the transaction. Let's say the client application is saying there is a variable called x is equal to current value of x is 20, and the request is to update the from 20 to 40, let's say, right? So the client do, the endorsers basically execute this proposed transaction, okay, and sure the read write RW set. Now the endorser does this, it sign that encrypted transaction and sends it to the client application. Okay. The read-write sets are sent back to the client application, and they also include something called as a version number, a record version number. This is really important when we talk about how do we check the double spend, and it's really important in the consensus process later on. Okay, so x is equal to 20, the proposed value is x is equal to 40, and let's say the version number is equal to 2. That means this is the second time that the value of variable x is getting updated. Okay. Let's see what happens. So once the client application gets all of these responses from the endorsement nodes, all of these is basically submitted to the orderer so that they can, order this and the other transactions in a form of a block, right? So if you see there, this red dotted line is basically submitting our response to the ordering service, and then there are multiple other applications which are sending their responses as well to the ordering service, right? Okay, let's see what next. So the ordering service collects all of these typical transactions and puts them in a block for distribution to the committing peers, right? Now, depending upon what ordering algorithm, Solo, Kafka, or Graph, whatever, the ordering service does this, right? Once the committing peer validates the transaction, against the smart contract pointer. Uh, it also checks whether the read-write sets are still valid for the current world state. Now go back to the same example, x is equal to 20, earlier value was 20, you want to update it to 40 and you said version number is equal to 2, right? So during the time when the client application submitted the transaction versus time till the node is validating this transaction, has there been any change in the value? Which may be because we're talking about big network here. There might be multiple committers, there might be multiple processes which are looking to change the variable x value and so on, right? So there can be multiple transactions happening in parallel there, right? That's where the committer would like to check whether the read-write sets are still valid for the current world state. That's where the version number comes and plays a major role here, right? So if the transactions are valid, the same are applied to the world state. That means the value of x from 20 gets updated to 40, right? And the reference of x is equal to 20 goes back into the blockchain, right? Okay, and once this updation is happening, the same is updated across all the peers which have which have that ledger which needs to be updated, right? So applications once registered has to be notified whether a transaction when a transaction succeeds, right? And each of the peers which their transaction looks like, right? So this is again the same way we talk about how the query is happening in a ledger, right? So we told that there is a smart contract S running on the node P1, right? And there is a query which is coming up to for something to query about a asset called car1, right? So once that is queried through the peer, the response is sent back, and then this can be done in all the other organizations. So each application typically queries their own organization's peer, right? I'll take a pause here, and there are a lot of questions on the chat. Let's quickly have a look at those. Okay. Somebody is asking what a private blockchain means. Okay, so let me try to explain this. I'll try to take a use case which may make sense to you, right? So let's say there is an affiliating university. I'm taking some random names, please do not connect it to anything, right? So let's say there is an affiliating university called ABC University, and this affiliating university has 20 colleges under this. Okay, and then there is another university called XYZ University, right? Which is again an affiliating university. Now, when you talk about the public blockchain, what it means is any organization, anybody can connect on that blockchain, right? When you talk about permissionless as well, then what it means is there need not be any explicit permission needed to join that blockchain. So hence public permissionless blockchain, right? Whereas when you're talking about a private blockchain, let's say in the case of this ABC University, right? So those 20 colleges which are affiliated to the ABC University are basically, and this is again a blockchain, right? So that means those 20 affiliating colleges have an identity through which they are connected to a private blockchain of ABC University, right? Now, here ABC University may look like one entity, but then there are 20 different organizations which are coming under the umbrella of ABC University, right? So, I'm just for this example. Please do not, misunderstand me. So, private blockchain is something where you govern who can join, what role are they going to play in that network, right? So, that's typically a private blockchain. So when you talk about enterprise means any organization, any company, how they use blockchain? They majorly businesses are done in private blockchains, right? But if you talk about like cryptocurrencies, Ethereum, and all, typically that's we talk about as public permissionless blockchain, right? Where anybody and everybody can actually join a network, do transactions, and all, right? Okay. So there is another question like what are popular job roles for a blockchain project in our enterprise world? Yes, sir, you're absolutely right. Developers are the one which are in high demand from a blockchain point of view, and then you have architects, who design the solution of those scrolls to a few more of them. Hyperledger means actually what? So Hype is an umbrella project under Linux Foundation, open source, open governance based. It's like, and hence there are multiple projects, multiple distributed ledger projects, multiple libraries which are. Hyperledger is a project under Linux Foundation. What is a ledger, right? So for example, the attendance register is a ledger, right? Somebody is asking what is a ledger. So ledger is nothing but a register. So attendance register is a ledger. What do you do there? You all the attendance, you are keeping record of some activity, right? So whatever transaction you do, you record that on a ledger, right? So that's what is a ledger. Why are we using Hyperledger? We're using Hyperledger because it provides for a great platform, for enterprise adoption. It's highly pluggable, it's highly modular, it's open source, open governance based, and hence it does not, create a situation of a vendor lock-in. When a certificate authority is used, doesn't the whole essence of avoiding third party gets dampened? Okay, so the certificate authority basically, I didn't get the question. So certificate authority can be internal, it can be external as well. So you can have a third party certificate authority as well, right? So in case you're on a network which does not want to have an internal certificate authority, you can obviously go for external, which provides for a lot more confidence and a lot more trust between the business network participants, right? Maybe you can rephrase the question, Poonam. Okay. Okay, so what's Fabric and Hyperledger Fabric? Okay, so Fabric is the framework, is the name of the framework, right, under Hyperledger umbrella. So under Hyperledger umbrella, if you remember, there was an infographic which talked about multiple projects, right? There was Hyperledger Roha, Hyperledger Sawtooth, Hyperledger Indy, Hyperledger Fabric, right? So Fabric is one framework for distributed ledger technology under Hyperledger umbrella. Is there a node treated as a base node in blockchain? All have same privileges? Yes, all have same privileges. That's why we talked about peer-to-peer networks over here, right? So no node has any special privileges when you talk about from a blockchain point of view. Log the attendance at the bottom, right? So let's say if there are 40 students in the class and the 27 are present in that class. So normally what you do is, when you are done with marking the attendance present and absent, you typically say 27 by 40, right? You lock it down. What are you doing it? By that way, basically giving nobody can later change the content or manipulate the ledger entries, right? The immutable ledger is where you can only write, you cannot edit, you cannot delete, right? So that's what is an immutable ledger. Okay. So it's really important. Also, from an IBM's perspective, we have a wonderful approach we call as a design thinking way of doing things, right? So in design thinking, right, and then what is the pain point for them, right? And then in that entire iterative process, we go back and forth and we find the just a moment. And we basically find the solution to this problem, right? So everybody needs to be brought on the same page before actually bringing or spinning up a blockchain network, right? So a smart contract is nothing but the business logic embedded into software. Now business